My
Is it fine now?
1 minute, let me check my. Yeah, yeah, please go ahead.
So, this is HDFS. So, you know, HDFS is Hadoop distributed file system. Okay. So, the key concept behind Hadoop is that Hadoop is a ecosystem to store and manage the large scale data set across the distributed environment. Okay, so like when the environment is not distributed, so let's suppose you are using Windows, so there is NTFS is there, and there is FAT32 file system is there. Then, if you talk about the Linux, there is ext file system is there. If you talk about the Mac OS, so there is APFS file system is there. In the same way, when we talk about Hadoop, this is HDFS file system. So HDFS file system is basically it is an ecosystem to store and manage the scale data set, large scale data sets across the distributed file system, across the distributed environment. Okay. So NTFS, FAT32, EXT, APFS, these are not the distributed file system. So this is not distributed file system. Okay, HDFS is the working under the distributed file system. So this is the one thing. Second thing comes is that since this is working on the distributed file system, it is highly scalable and very much fault tolerant. Okay, it is very much fault tolerant because the data is distributed. The data is not in single system. If you talk about the NTFS, FAT32, EXT or APFS, data is not distributed. So if any point of time any of disk goes out of function, what will happen? The entire system will get corrupted, and your data, there is a high chances of missing of the data or loss of the data. But in case of HDFS, it is highly scalable, and since data is distributed, because of that, it is very much fault tolerant. Okay, and so um, unlike the traditional file system, HDFS is optimized for big data. It is basically optimized for the big data. Big data, when you say, we say big amount of data, right? So the limit of data storage over here is like in if you talk about in NTFS, FAT32, EXT or APFS, hardly there is the capacity of maybe at a time if you work in these systems. So what will happen? It works on the RAM size. So suppose if RAM size is 8 GB at a time. Okay. So since these are the traditional file systems. These are the traditional file systems. Okay. So when we talk about the traditional file system, in traditional file system, um, process is dependent on the RAM size. Okay, no matter what your hard disk capacity is there, but speed and work, everything will depend on the RAM size. So if RAM size is lower, definitely there will be a limit of the data processing. And if the big amount of data has come, so let's suppose you one is using just the 8 GB RAM in the system, which is very good for a normal level system. But now when we talk about the this big amount of data means at a time, every day or every let's say every day 10 GB, 20 GB data is getting generated. So at that point of time, 8 GB size will not be able to cope up with this traditional system, right? So because of that, this big HDFS is optimized according to the big amount of data. And since this is a distributed, so creates the processing of the data chunks very easily, and recovery of the data is flawless, right? If any kind of data misses, so it can easily be recovered with the other connected system. So that this is the HDFS. Now, let's see some terminologies under HDFS. So when we'll implement, we'll use these terminologies. So first of all, there is a file system. So as we discussed, there are different kind of file systems are there. So file system, if we say file system is layer between the and software and hardware. So software, you all know. Then hardware, it may be the HDD hard disk or SSD hard disk, anything it can be, right? So there can be that in single system there can be different kind of things, and then different kind of file systems can be there. So if you are using if you are using the Linux, so you will be using ext file system. If you are using Windows, you must be using NTFS or FAT32. Basically, these, or if you are using suppose Mac, so there is APFS is there. So what this decides is, uh, it determines how data is being stored inside the system, right? So it also decides about the graphical user environment, that is GUI normally we call, or we say whatever the permissions may be there, or any kind of integration, right? Any kind of integration, because lot of softwares which you use may require the installation process. So to create the to initiate the installation process, there can be the DLL files can be there, then executable files can be there, then extension files can be there. Mm, extension files can be there. So lot of things require, a lot of terminologies require, lot of processes are required. So here if we say there are the auto system processes are there which run in background, and while running it occupies a big amount of RAM. So, for example, if you are using, let's say, 16 GB of RAM, if you are using, so this file system, whatever NTFS, EXT, APFS, whatever you are using, out of 16 GB, at least 2.5 GB will be required to run these file systems. So if you have a 16 GB RAM, so you have only the availability of 12 to 13 GB only for your own system running process, right? If you are exceeding those processes, your system will will start hanging. Okay, so when we these are the file system which are required for the operation of operating system. On the top of that, there is HDFS, right? So um, this is distributed. This is distributed file system. Others we discussed, they were not distributed. So what it says is that one machine can have different number of file systems. It can have the different number of file systems, and data can be exchanged among all this. Okay, so what it does is when you install HDFS in your system and you allocate memory for this, what it does is it internally creates its own partition, and those partitions are treated as a separate workplaces, right? If you talk about the Windows, so usually C drive is the workplace of the entire system, no matter in which in which location you are running the program. Ultimately, for execution, every program has to come into the C drive. In the same way, for the Linux file system, whatsoever partition you are using, when you have to execute something, you have to make something changes. Ultimately, you have to come back to the ext system. In the same way in Mac also. But in the HDFS, when you are using the HDFS, at a time it creates the number of partitions, and these number of partitions then further can be uh, exchanged for yeah. So this can be so that the spaces can be exchanged among this, right? So now basically you can say like when you have um, you have a system. Let's say this is a system you have. So usually these systems are running on the Linux OS. Most of the things are running on the Linux OS in HDFS. So let's say in Linux you have a extension file is there, right? And then you have a hardware over here. So you are taking a hardware. Where it is. So let's say we have where is there pen drive in this system? Okay, so let's say we have a hardware like this. We have a hardware like this. So this is our hardware. So this is our hardware. Now, when we have to interact this with this. So this is the main hardware system. So here there is one side, there is OS. This is our OS. And on other side, this is the hardware. Okay. Now we have a middleware over here. So this system, this process is known as means this middleware is known as file system basically, right? So for example, if you have a Linux system, let me go back. So if you have, let's suppose you have a Linux system and you are connecting a pen drive. So this is a pen drive. You are connecting to a pen drive. It automatically opens all the detail in pen drive in the manner it is designed inside the Linux, right? So it adopts this hardware adopts the file system of whatever defined inside the Linux. In the same way, let's suppose this is a Windows system is there. Now, when you are inserting a pen drive, what will happen? Again, it will interact with the with this file system over here in the Windows system, and it will store the information. So you can see there is no own system of pen drive. Pen drive is a hardware, and it is storing the data as well. But what's happening is that data can be as it is, it can be used by the Linux system also, and as it is, it can be used by your own Windows system also. So operating system of pen drive is capable of interacting with both Linux and Windows, and if you will insert the same into the Mac OS also, it will adopt the Mac OS. So what file system is doing is file system is doing an interaction platform between the operating system and hardware, right? So here the main um, benefit of doing this is the data exchange. Okay, data is exchanged over here between the hardware and the software. So by this file system is working. So basically, um, if we in most industries, Linux is very good and efficient for the this Hadoop processing. Efficient for the server level Hadoop processing. Okay, any doubt on this? Okay,
No.
okay. So this is the first thing, that is file system. Second thing that comes is that is main is block. So what is block? So what block is known as the smallest unit of data storage in file system. Okay, smallest unit of data storage in file system. Okay, now let's say if you are using the NTFS or FAT32 if you are using. So basically the block size over here is um 4 KB. Okay, but when you talk about the HDFS file system, so the block size will be 128 MB. You imagine the difference in NTFS and HDFS file system. So in NTFS there is block size of just 4 KB only, and this now in this let's suppose you have to store the size of 10 KB. So what it will do, you would require three blocks of 4 KB to store this 10 KB data. Okay. Mm, wait 1 minute. So what will happen is it will require three blocks to store 10 KB data. But if the same thing we are doing with the HDFS, so in HDFS, since the data is very large, because of that, um, this HDFS requires the bigger data size, right? So now what no, the difference between the NTFS and HDFS is that in NTFS or FAT32, if you talk about block size is fixed as per the OS standard. Okay, but in case of HDFS, block size is not fixed. Okay, block size can be varied as per the need. Now, since this block size can be increased and it can be decreased also. So, what happens is if let's suppose um, there was a huge need of creating it like this because when data was coming into this system, so it was a very big amount of data. So in NTFS or FAT32, if you are copying some data from one place to other place, you can, can see it can take time. Even it is within the local system, it is not on network. Then also it will take time because of the smaller block size. And as soon the block size increases, in the same way the data size is also getting
So how
data
we
size is
increase the
also
size of HDFS?
sorry.
How we increase the size of HDFS?
That
So
will
it,
keep how we are increasing the size of HDFS. Right now, what I'm telling is just what it is there inside the HDFS or in NTFS, right? So let's suppose you have a data of 100 MB to be transferred. You have a 100 MB of data is there to be transferred. So 100 MB of data will be divided into the chunk of 4 KBs. So what will happen is 100 MB means you can say around 1 lakh KBs. It will be around that, and one lakh KBs. 1 lakh KB divided by 4. There would be the requirement of 25,000 blocks. Okay, now to transfer the 100 MB data, it would require the 25,000 blocks. Okay. So which is going to be very much hard for the system. So right now the system capabilities has been increased to 100 MB is nothing. But for a general perspective, I'm telling if your data size is 4 KB, so it may be very much tedious for system to manage this amount of data. But when you are using the HDFS, size of 100 MB will be nothing for him because it is just a one block, not even the one block size, right? Now, let's say you have data of, let's say, 1000 MB data is there. So if 1000 MB data is there, what Hadoop does is it divides the data based on the whenever the data processing is required or data transfer is required, divide the data into a manner so that each part is each part is of equal size. So this is the this is the limitation for this. So if HDFS finds that the blocks are of equal size, then only it will process them further. Otherwise, it will not process them further, right? So what will happen is now it cannot engage. Uh, just this 1000 MB data can only not be engaged by just 128 MB block. So it would require around 6 to 7 blocks, right? So what it will do is it will divide 128 MB data. It will or based on the requirement, let's suppose it can convert its block size 128 MB to 100 MB, and then 10 blocks of 100 MB 100 MB will be used to transfer the data. Okay, so here you can understand when it is doing when it is dividing the 10 blocks of 100 MB. So you can see if this um, if this 100 MB is taking let's say no, 10 seconds to get executed, here the same time will be taken for the 1000 MB as well, because now these blocks are divided into 10 equal blocks, which is of 100 MB, and each 100 MB will be loading its 1000 MB at a time. So the local file system, it will take to store 100 MB in, let's say, 10 seconds. Here also 100 MB will be taken by just 10 seconds only, and there will be 10 parallel processing. So because of 100 MB is being transferred in just, let's say, 10 seconds. So 1000 MB will also be transferred in just 10 seconds only, because 10 simultaneous system will be working at a time to transfer this data. Understood?
okay.
Yes, no?
Yes.
Okay.
You hear me? Mm,
Yes, 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 I can hear
yes.
you.
Yeah. Mm.
Okay. So this is the advantage of using the block in HDFS. So and this is the reason HDFS is considered much more faster than the traditional file systems.
Okay.
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 Then third system in this is types of file system. Okay, so types of file system, and where first type is standalone system, and second type is distributed. Okay, distributed systems. So in a standalone system of let's say we have three different nodes. We have this is the first node, then this is the second node, and this is the third node. Okay, these third nodes are there. Now let's say all these nodes are the Linux based system. So these are the Linux based system, and these Linux based system are using the ext file system. Okay, and here all these systems are connected together over here. All these systems are connected over here towards with the network. So this is these all these are connected, right? Or um, since all these are connected, let's say if I have if I have something to transfer, let's say I have different files to transfer. This is a one file that I have to transfer. Then there is a second file that has to be transferred. Then there is the third file that has to be transferred. So we have different number of files have to be transferred. So what will happen in this, since topologically if we go, you know the topology,
No.
you know topology.
No.
Topology is the concept of computer network where there is star topology, there is a bus topology, there is different kind of topologies are there. Just go back to your own computer networking notes and just study what is topology. So you just need to know the meaning of the topology. Okay,
Okay.
I'm not going to explain that in detail. Just have the get the notes of computer network somewhere, and you will find what is topology. Okay.
Okay.
So now topologically what we do is this is one system, and in the distributed system there are let's say these all are systems. So we have three system H, P, A. Okay, so we have here this is system one, this is system two, and this is system three. In the same way, in distributed system, this is distribution system one, this is distribution system two, and this is distribution system three. And all these systems are also connected together through the network. So this is connected to this, and this is connected to this. Now, what's happening is now when one file comes over here, so immediately this file will go on for first system. Then this will go on this system. Then this will go on this system, right? So what's happening is anything that comes first, it will be directly transferred to the first system only. Okay, when first system will not be available to take call, then this will be transferred to second system. When second system will not be available to take call, it will be transferred to third system. So here the next system is being preferred only when previous system is not available for taking the section or taking the call, or it is full of its capacity. But the same thing if we talk about the distributed system. So let's say we have one node, one task is here. This is then the second task is there, then there's third task is there. So what it will do is it will not assign all the tasks to one system. So first task will be assigned to first system, then second task at the same time will go to second system, and third task will go to the third system. So what it is doing is it is basically just using the available space efficiently, right? Wherever someone is free or some system is free, task will go to that system directly. So if we say that the structure of connection, so here this is connected to this is connected to this, and here also with one wire, D1 is connected to D2 and D2 is connected to D3 with the one wire only. So what we say is topologically both are same. Okay, but what is the differences? Differences under the files storage and management system. So under the traditional system, what used to happen that everything will be managed by a single window system. Single window system is created in the traditional system, but in the modern system, if we talk about in the cloud systems, files are stored across the multiple machines. Okay, files are stored across the multiple machines, and these multiple machines are responsible. These multiple machines are responsible for their own data storage. So let's suppose document has one has go to D1, document two has gone to D2, and document three has gone to D3. So everyone is responsible for whatever the document is being processed. So all these systems are comprising the HDFS in it. Okay. So at the same time, multiple system can do the similar task, and speed can be increased like anything in HDFS in this way. Okay. Okay.
Mm-hmm.
Okay. When then the next thing here, let me highlight. First terminology is file system. Second terminology is block. Third terminology is types of file system. And so there is two types, standalone and distributed. And then fourth system is clusters and nodes. Okay. So when we talk about let's say I have one system. This is my one system. This is my second. This is my second. What's happening? Why it is creating fish? Where is rubber? Highlighter, drawing, pencil. There is no rubber over here. Eraser. Where is eraser? Highlighter fountain. No eraser in this environment. Okay, so this is one system, this is our second system, and this is our third system. Okay, So, and all these systems are connected together. So, all this system is connected to this. These systems are connected together over here, and these systems are connected like this. Okay. So, here the systems that store the process is known as node. So, this is node 1, this is node 2, and this is node 3, right? So node is something that is, let's say, we say a node is something that handles the process independently. Okay. So let's suppose task has come, you have given one task to n1. So n1 will handle this task independently without any uh, without any intervention. Now, next task come. So the system sees that this N1 is busy, so automatically it will go to N2, and then that task will be executed by N2, and it will not connect with N1 for any kind of output or process. So these are all the nodes are the independent system. Then second thing comes is cluster. So the cluster is the combination of small group. So this combination of a small group is means this entire system. If you say this entire system that you are seeing, this entire system is called as cluster. Why this is cluster is because here similar kind of documents are coming. So suppose one first task is there that is being performed by this, and then second task is there, it is being performed by this, but tasks are similar. So in the same group the similar kind of tasks are being performed, so that's why it is known as clusters. Okay.
Okay.
So cluster is basically the combination of a small group to perform some to perform some specific task. Okay. And then fifth thing is process and daemon process. This is one very important terminology. So
Mhm.
process is something that is a program in execution is called as process, and the daemon process is basically a process that runs without without any user intervention. Okay. So can you tell me the example of any process that is running without the user intervention?
Any process,
Any process that is running without the user intervention.
yeah, or like automated process,
Like,
automated email.
no. So automated process is something which do not require the um, user support. So let's suppose you have I'm opening this task manager. So in this task manager, you can see uh, I am using just this Excel. Okay. Rest few programs are there, like WhatsApp is there, Notepad is there, and this Google Chrome is there. These things are there which are running. But apart and whenever I would require, I would go to that part and I'll execute that by myself. So those are these all are the tasks which are running by my intervention. Any of this, either Google Chrome or Microsoft Excel, Notepad, Task Manager, WhatsApp, Windows Explorer. All these apps are there which are running without my intervention. Now, You can see after that there are many other processes are there. These are the background processes, right?
Mm-hmm.
And all these background processes are running without my intervention.
Correct.
Understood?
Yes. Yeah.
So all these processes are there which do not require my input, but they are still important to run the entire system's job. Okay, so lot of like audio system is there, or antivirus is there, or video system is there, and Microsoft Office is there. All these systems, all these processes are running in the background. They don't need me to run. They are running automatically.
Okay.
Okay,
Mm-hmm. Yes.
then this is the difference between process and daemon process. Then sixth one is metadata. Do you know what is metadata?
Data within data.
It is not data within data, it is data about data. Okay,
Okay.
data about data. So, for example, if you have a book, so in book, lot of things are there inside the book, but starting of the book, in the starting of the book, there is index. What is that index?
Um, so index is to find out the
So it
uh,
is basically a data which tells that inside every chapter what all things are there.
yeah,
Yeah. Okay, so that index is known as metadata. That is data about data. Your data is the book, but about that data where you will get information. So if suppose you have to search a topic, so first of all you will go to the index and see that in which chapter that topic exists, and
yeah,
then you will directly on that pages, those
yeah,
kind of pages,
yeah. It helps to
right?
look. Yeah. Mm-hmm.
So that is data about data. So like index in your book is data about data. So what it is doing is it aligns aligns all the data in a way so that it can be searched in efficient way. Okay, it can be searched in the efficient way, and storage can be managed easily. Okay, so this is the metadata, and the seventh one is replication. What is replication? So replication is basically process of making copies of our data. So since if we are making, so makes multiple copies of one data, and stores it in archive manner. So by storing the copies into the archive manner, what it does is it reduces the possibility of the data loss and makes data more fault tolerant. Okay, so are you clear with these things?
Yes.
Any doubt with this?
No, I'm good, Kushal. Yeah.
Okay. So now why we use HDFS? Why we use HDFS?
Kushal, shall we finish off this until this today?
Sorry,
Shall we finish up with this today and until this today?
I didn't get you.
No, shall we